All right, so we're going to take a look at our introduction to functions. Some of this might be review for some of you guys, but some of the quick definitions that we want to make sure that we're good with. So a relation. A relation is going to be a mapping of x values to y values. And there's a few different ways that we could write these things out. So some examples of relations, we can write them as points. So maybe the point 2, 3, and the point 4, 6, and the point negative 1, 2. That's a relation. You could write them in a table. So we could put our x and our y. So the x would be 2, the y would be 3. And we'd have 4, 6, negative 1, and 2. So we could do it as what some of you guys have probably seen before when you learned about functions in terms of a mapping where you put the x's in one oval and the y's in another. And so you put your 2, your 4, and your negative 1, and your 3, your 6, and your 2, and then you would map. So the 2 maps to 3, the 4 maps to 6, the negative 1 goes to the 2 there. And then we could also graph relations. So if all of a sudden I had the equation y equals 3x plus 1. That probably looks something like that line. So we can graph relations as well. One particular type of relation that's that we're going to focus on in this particular unit is called a function, and that's a relation in which every x maps to exactly one y. So and determine whether the following are, these are all relations, but are they functions? So we can see 3 goes to 5, 2 goes to 5, and 4 goes to 6. So if we were to put this in here, 3, 2, and 4, and then we put our y's, we got 5 and a 6, so we don't need a repeat. So does every x go to exactly one y? Well, 3 goes to 5, 2 goes to 5, and 4 goes to 6. This is a relation because each x goes to exactly one y. Now we look at number 2 and put 1 and 2, right? We got a 1, and a 2. And then in our y's we have 3. Let me make that a little bit bigger so we can see it. We have a 3, an 8, and a 7. Still need to make it bigger. 3, 8, and 7. And here, 1 goes to 3 and 1 goes to 8 while 2 goes to 7. You can see right here because 1 goes to 2 places, this is not a function, right? Each x doesn't go to exactly one y. All right. So we'll scroll down just a little bit. Oh, it's not going to move with me. That's no good. Well, we'll take a look very quickly at this one. We'll just have to kind of cram it together. And you can just kind of look 2, 1, and 5. Another way to look at this, does x repeat? And if x doesn't repeat, we got 2, negative 1, and 5, excuse me. None of those repeat, so this is a function, yes. That's another way to look at it if you don't want to do the maps like we did in 1 and 2. In this one, it goes 3, 5, 7. X does not repeat, so this again is a function. So we'll move down here to something that's called the vertical line test. And what a vertical line test is for a graph to be a function, a vertical line um, can only touch the graph once. So if you look down here in that example that's at the bottom, if I were to draw a vertical line right there, it does not pass the vertical line test, so this is not a function. Domain, these are all x values, and then the range will be all possible y values. And so what we're going to do in order to do this is something that's called interval notation, and it's actually pretty straightforward. What you want to do for domain, right, is we want to take a look, and the x's go all the way from 1 up to 5. So one way to do that, you could do x between 1 and 5, You can see that it touches 1 and it touches 5, so it's less than or equal to and greater than or equal to. But in function, or in, excuse me, interval notation is actually a little bit easier. You do a square bracket where it starts, a comma, the number where it ends, and then close it with that bracket right there. The range, all possible y values. So here we're going from 1 up to 5. So again, we could write it y is between 1 and 5, but probably what most of you guys are going to really start to like is this interval notation because we're going everywhere from 1 to 5. And we use the square brackets because 1 and 5 are included. All right. So let's flip the page over to 2. And on page 2, we're just going to go through some examples. So is it a function? So draw a vertical line, and if a vertical line can touch 2 points at once, and all of a sudden if I draw one right here, you can see it'll get both of those points. So this is not a function. Look very carefully. I'm going to actually highlight the points a little bit. We're here, 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 and here it looks like. So the x's are going everywhere from, looks like -3 up to what looks like 4. So my domain is from -3 to 4, and it's inclusive. The range here, it looks like we're going from -4 there all the way up to 5. So we're going from -4 to 5, and we're going smallest to biggest. Number 2 here, vertical line will definitely touch more than one point at a time. So this again, not a function. It is a relation, but it's not a function. The domain, we're going everywhere from -2 up to +2. And then in terms of a range, right, we start down here at -4, we go to +4. So -4 to 4. Number 3, we have a segment. Does it pass the vertical line test? Any vertical line I draw in here will only touch that graph once. So here's an example of something that is a function. So this relation is a function. So if we go left to right, it looks like we start at -1, 2, 3, 4, and we go up to +3. So the domain is -4 to 3. And then the range looks like it starts at -1, and it goes up to 1, 2, 3, 4, 5, 6, if I'm counting correctly. So we go from -1 to 6. So domain will go left to right, range will go up and down. Let's look at the next few examples. Again, vertical line, it'll touch that circle more than once, and we can draw actually quite a few. It'll fail the vertical line test multiple times, so not a function. Here to get the domain, looks like we're going from -2 up to +2. And those, we're going to use the brackets. And then in terms of range, we're going to start at 0, and it looks like it goes up to 4. So we'll go from 0 to 4. Here we've got some kind of parallelogram. And again, vertical line touches it more than once, so this is not a function. And now it's just a matter, we have to look very closely. 1, 2, 3, 4. So it looks like it goes from -4 up to 1, 2, 3, 4, 5. So our domain, let me kind of erase what's up here, is from -4 to +5. And then my range looks like it goes from 0 up to 1, 2, 3, 4. So my range is from 0 to 4. Here we got an oval that's sideways. Again, vertical lines will touch this many, many times. This will fail the vertical line test. And that's the thing about the vertical line test too. You only have to fail it once. Like you saw up here, number 1, it failed it once. Those 2 points both touch that vertical line. If we look back at number 1, that's all it takes is once. So again, it could fail it multiple times, but if it does it once, it's out. It's not a function. But we can still find domain and range. So domain, looks like we're going from 1, 2, 3, 4, 5, -6, right there, up to 1, 2, 3, 4, 5, 6. So we're going from -6 to 6. And then the range looks like we're starting at 0, and we're going up to 1, 2, 3, 4. So again, from 0 to 4. We'll go ahead and finish up this page very quickly. We can see multiple vertical lines will touch that particular relation more than once. So again, not a function. Most of these turn out not to be a function. But this is a good one. We can see the domain. We're going to start at 0. And this keeps going on and on and on. And so the way that we can indicate that as infinity. Now this is the first time you're actually going to see this. So we're going to start at 0. And when we go up to infinity, we're not actually going to put a closed bracket, but because infinity goes on forever, we have to use kind of an open parentheses. That means that it goes to here, but we can't ever actually get there. And then you can see with the y's, this function is going to keep going down forever, and it's going to keep going up forever. So it's going to go down to negative infinity and up to positive infinity. So we're going from negative infinity to positive infinity. And because it's infinity, we're not going to put the square brackets, we're going to use parentheses. All right, I guess this would be number 8 on the page, but it's listed as number 2 here. Vertical lines, really, I can try all sorts of vertical lines. None of them are going to touch this function twice, or this particular graph twice. So this is a function. Yes, it passes the vertical line test. The domain, we can see it's going to keep going on this way forever to the left and forever to the right. So we're going from negative infinity to positive infinity. Right? It's just going to keep going left. It's going to keep going right. That's what those arrows tell us. It's going to keep going and keep going. This definitely has an endpoint down here at the bottom. It looks like 1, 2, 3, 4, 5. It looks like it starts at negative 5, but as we can see, this is going to keep going up and up and up, and it won't ever stop. So in other words, we're going to start at negative 5, and then we're going to finish at infinity. And then here, well, it is a vertical line, and a vertical line will touch that entire line the whole time. So it's kind of tricky, but this actually is not a function. The domain, well, it's just at 1, 2, 3, 2, 3, 4. So the domain here is just 4. It starts and stops at 4. In the range, we can see this thing's going to keep going on forever up. It's going to keep going forever down. So it's going to go down forever, and it's going to go up forever. So the way that we show that is with the infinities.